Hello, everyone. Welcome back for another math lesson with Mr. Hopkins. Today we're going to start off with a review again before we get into what exactly is a quadratic. So first, let's factor these following expressions. So back in Unit 3, we also factored by means of GCF, and then we used the parentheses. So in the first one, always look for a GCF. So between the two numbers 3 and 9, do they have anything in common? The answer is yes, they have a 3. And then between x squared and x, the most x's they have in common is 1x. So when I factored that out, I just divided it out of each term. So 3 divided by 3 is 1. If I take 1x away from 2x's, there's 1 in there. Bring down the minus. 9 divided by 3 is 3. If I take the x away from the only x, there's no more left. And then to check our work, we would distribute. So 3x times x is 3x squared. 3x times negative 3 is negative 9x. So I didn't change my answer any. I just changed its appearance. So that's factored. This next one is a trinomial. Trinomial right there. There is no GCF, so then we look to factor into parentheses. Factors of the first term, x times x is x squared. And then I look for factors of the last term that add to get the middle term. So factors of 36 that add to get negative 5 was negative 9 and positive 4. They add to get negative 5. They multiply to get negative 36. And the last one, again, there's no GCF in this one, so we look to factor into parentheses. X times x was x squared. And this one is a little special. It's missing that middle term that this one had. So really the middle term is 0. So what are factors of 25 that add to get 0? And that would be positive 5 and negative 5. They add to get 0, and they multiply to get negative 25. Okay, so that was a quick review on factoring. That, again, was from Unit 3 or 4. We cannot forget this. It will stay with us. Okay, so standard form of a quadratic equation is right here. Y equals ax squared plus bx plus c, where a, b, and c are just numbers. But the most important part is it has an x squared. So what it must have is x squared and nothing more than that. It can have an x and it can have a constant, but it can't have anything higher than a 2. It cannot have square roots. It cannot have variables in the denominator. It cannot have negative exponents as variables. Variables raised to negative exponents. Let's start with that. If we find one, I already told you can't have anything bigger than 2 as an exponent. Okay, so having said that, it says circle the choices below that are quadratic functions. Well, this one looks good. That's a quadratic function. This is bigger than 2, so no, not that one. This has a square root symbol with a variable inside it, so not that one. And this looks good. Those are quadratics. Excellent. So finding zeros. Zeros are where it crosses the x-axis. So it says on the graph, find and circle the x-intercepts, or y equals 0 in the table. So find the zeros of each quadratic function graphically. So let's start with number 3 because that's the easiest. It's already there. Well, the zeros are here and here. So that's when x equals negative 4 and when x equals 0. That's my answer. Now these other two, let's use our calculator. Turn our calculator on. We go to y equals, and let's put in x squared minus 7x minus 18. X squared minus 7x, x squared minus 7x minus 18. And let's go to graph. Where it crosses the x-axis are the zeros. So it looks like we have -2 here and 9 here. So x equals -2 and x equals 9. Those again are called zeros, also known as roots. We may see it written either way. They could be called the roots or they're zeros. Now another way is if I went to the table that's second, then graph, I'm looking for the zero. When does y equal 0? Well, right here when x is 9. And then we also find one on the other end, -2. So you may have to scroll up or down. Okay, we have one more. 2x squared minus 8. Clear out what's there. 2x squared minus 8. Go to the graph, and we have x equals -2 and x equals +2. Those are the zeros. So finding the zeros, that was graphically. We're also going to find the zeros algebraically. And today we are doing that by factoring. In the future, we'll learn by completing the square, and we'll learn by the quadratic formula, which is in the next chapter. So method 1 is to factor. Here's the steps. Set the equation equal to 0, factor it, and then we'll t-bar it and set each factor equal to 0. So here we are. Step 1 was set the equation equal to 0. So I have x squared minus 16 equals 0. There's no GCF. Step 2 says to factor it. So we have x times x is x squared. Factors of 16 that add to get 0 because there's no middle term is +4 and -4. Step 3 says t-bar. What that means is split the factors. So it kind of looks like a T. So we call it a t-bar. And set each piece equal to 0. So I have x plus 4 equals 0. And then on this side, it's x minus 4 equals 0. And then I'll solve for x in each case. So subtract 4, x equals -4. And over here, x equals +4. Okay, number 2. And these are the zeros. So if I was to graph this and go to y equals, just so you can relate it to what we were doing graphically, x squared minus 16, go to graph, and it's going to cross at -4 and +4. Okay, we are again, x squared plus 5x plus 4. Set it equal to 0. That's step 1. Step 2, factor. Factors of 4 that add to get 5. Well, the only factors of 4, 2 times 2, can't come up with 5, can we? Or 1 times 4. Ooh, boom. 1 and 4. They add to get 5 and they multiply to get 4. T-bar it. X plus 1 equals 0. X plus 4 equals 0. Solve for x. If I subtract 1, and over here, if I take the 4 to the other side, you get x equals -4, right? There's your 2 answers. And lastly, if I set this equation equal to 0, I get x squared minus 10x equals 0. I have to factor this. X minus 10 equals 0. And then t-bar it. So this one has a GCF. It's different from the other two. X equals 0, that's already solved for. And over here, x minus 10 equals 0, so therefore x equals So that is solving for the roots, also known as the zeros, where we factor in set equal to 0. Tough lesson today, and we will review it again in the next lesson. If you have any questions, please reach out.